All right, welcome to the Explainer. You ever write some .NET code, hit that run button, and just wonder what happens next? Like, how does it actually work? Well, it's not magic, but it's pretty darn close. Today, we're going to pull back the curtain on the powerful engine that makes it all happen, the Common Language Runtime, or as you'll hear me call it, the CLR.
So to really get this, we're going to follow a single piece of code on its entire journey. We'll start with the engine itself, then see how it loads the blueprints, juggles memory, turns that code into action, and finally how it's protected by some runtime guardians. Let's get into it.
All right, first up, the engine of .NET. Let's get to know the absolute hero of our story, the thing that makes the whole .NET world go around. So what is this Common Language Runtime, really? Well, you can think of it as the core execution engine for all .NET programs. It's kind of like a mini operating system that's just for your code. It creates this managed environment that sits between your program and the actual OS, handling all the nitty-gritty details for you.
And this is the magic right here. Because of the CLR, you can write your code once, and it'll just work on any computer. Windows, Mac, Linux, you name it. You don't have to change a thing. It's that classic write once, run anywhere promise, and it's a total game changer because the CLR takes care of all the messy translation work. Okay, so this is basically our roadmap for the rest of this explainer. Every single piece of your code goes on this exact journey, guided by the CLR. It gets loaded, memory gets allocated, it's compiled, executed, and all the while it's being managed and protected. So let's dive into that first step.
Okay, step 1, loading the blueprints. Before anything can happen, the CLR has to actually get your code into the system. But how does it do that?
Well, meet the first piece of the puzzle, the class loader. Its whole job is to find the blueprints for your program, your classes, and pull them into memory. But, and this is the really cool part, it doesn't just dump everything in at once. It's much, much smarter than that.
See, the class loader is incredibly efficient. It follows a simple rule. If a piece of code isn't being used right now, it isn't loaded, period. It literally waits until your program says, hey, I need this specific class, and only then does it pull it into memory. This is huge. It saves a ton of memory and is one of the key reasons your .NET apps can start up so quickly.
All right, next up, the memory juggle. So our code's blueprints are in. Now we need a place to actually do stuff, a place for all the data and objects that our program is about to create. So where does all this data live? Well, the CLR basically has two neighborhoods for it. First, you've got the stack. Think of this as super fast, super organized, short-term storage. It's perfect for things like local variables that only exist for a moment. Then you've got the heap. This is your long-term storage. It's a bit slower, but it's a huge, flexible space for all your objects, the things that need to stick around for a while. And who decides what goes where? That's the job of the memory manager. This component is basically the traffic cop for all your program's data. It looks at a variable and says, you're temporary, go to the stack. It looks at an object and says, you're going to be around for a while. Go to the heap. It expertly manages all of this so your program runs smoothly. Okay, so the memory manager is great at handing out space. But what about cleaning up? In any program, things eventually get old and aren't needed anymore. If you just leave that old data lying around, you get what are called memory leaks, and that can bring your whole application to a grinding halt. So, who cleans up the mess? Well, let me introduce you to my favorite component, the garbage collector. And the garbage collector, or GC, is an absolute lifesaver for developers. Its job is simple but so important. It periodically scans the heap, looks for any objects that your program isn't using anymore, and just poof, gets rid of them. It automatically frees up that memory for you. It's like having a robotic cleanup crew that means you, the developer, almost never have to think about manual memory management. All right. Code into action. We've loaded our blueprints, we've sorted out our memory, now it's time for the moment of truth. We need to turn our high-level code into something the computer's processor can actually, understand and execute. But this brings us right back to that big, important question we asked at the beginning. If the guts of a Mac are totally different from a Windows PC, and that's different from a Linux server, how on earth can one single program run on all of them? The answer, and this is really the secret sauce of .NET, is the just-in-time compiler, or JIT. See, when you write your C# code, it doesn't get compiled directly into machine code for a specific computer. Instead, it gets compiled into a generic middleman language called intermediate language, or IL. Then it's the JIT compiler's job to do that final, crucial step. It takes that generic IL and translates it into the native machine code for whatever computer you happen to be on.
And you might have guessed from the name, but just like our smart class loader, the JIT compiler is also super efficient. It translates the code just in time. It doesn't compile your whole program at the beginning. Nope, it waits until you're about to run a specific method, and only then does it compile that one piece. This makes everything feel fast and responsive.
And finally, we get to the runtime guardians. Our code is now compiled and it's actually running, but the CLR's job is far from over. It's now acting like a team of vigilant guardians, constantly working in the background to make sure everything stays safe, stable, and running right.
Think of it like this. You've got this whole management team on the job. The thread manager is like a master juggler, letting your app do multiple things at once, without dropping the ball. If something goes wrong, and let's be honest, things always go wrong, the exception manager is your safety net, catching errors gracefully so your whole app doesn't crash. And standing at the door is the security manager, acting like a bouncer, checking IDs and making sure no code tries to do anything malicious.
So when you put it all together, you realize the CLR isn't just one thing. It's a whole collection of essential services. It's a complete, managed environment, an entire ecosystem that works together to bring your code to life safely and efficiently.
And this really is the bottom line. The CLR takes care of all the hard stuff, all this complex low-level plumbing. Managing memory, ensuring security, compiling for different machines. It just handles it. And that is incredibly liberating for a developer, because it means you can stop worrying about the plumbing and start focusing on what really matters: building amazing things. Which kind of leaves us with one final thought, doesn't it? This whole incredibly sophisticated system is there to do all the heavy lifting for you. It manages memory, it handles security, it deals with execution. So if you don't have to worry about any of that, what amazing things could you build?